السلام عليكم ورحمة الله وبركاته. يعطيكم العافية شباب وصبايا. معكم دكتور بشار جوارنا. Today we will talk about the last part of chapter 13, which is fluid mechanics, part 5. So our subject for today is the rule of gravity in the circulation. In general, we are talking about the effect of gravity on the pressure inside our bodies. At the beginning, we have to know that our fluid is the blood. Therefore, the density of the blood is roughly about 1.06 times 10 to the power 3 kilogram per meter cube. Now, in general, or in this subject, I will talk about when your object is laying down, reclining, or when our body is standing, erect. So, as you can see here, this is my body, where the body here is laying down, and I'm looking for 3 points: feet, heart, and brain. In this situation, you need to know the following: the pressure everywhere are almost the same, whereas the small pressure dropped between the heart and the feet, or between the brain, and all of this is due to the viscous forces. The second situation, where is the body, or your body, your body is standing up. In other words, we are talking about erect position. From here, you can tell, if we let us take the feet here, the height of the feet from the ground as y or h feet, which is 0. Therefore, we can tell we have 3 points: feet, brain, feet, heart, and the brain. In general, and roughly, the distance between the heart and brain or the head is 0.4 meter, and the heart and feet 1.3 meter, and between the heart and brain is 1.7 meter. These values is for adult people. Now, when the body, or when your body in this situation, I mean the standing situation, the pressure is obviously here is different, and the height are different too. Now, to analyze or to calculate the pressure difference between your feet and heart, or between heart and the brain, we are going to use Bernoulli's equation. And we all know Bernoulli equation in this form. I'm trying to calculate the pressure between the feet and heart, and you can calculate the pressure between the heart and the brain. Now, as I mentioned at the beginning, the height here from the ground, from your feet to the ground, because we are taking the ground as our reference, therefore the height, or h or y feet, equals 0. So this term will be 0. Now, the velocities here, how can I say it? This term and this term are ignored. Why? Because the arteries are very, very small and roughly equally. Therefore, the velocity here and velocity here equally and cancel out. So the rest will be the pressure due, or in the feet minus the pressure due to the heart, will be the density, the blood density, times the gravity, times the heart height. As a conclusion or a summary, the pressure in the lower and upper part of our bodies are very different when the person is standing, although they are about equally when your body is laying down or reclining. Now, let me go back when the body in standing position. Therefore, the acceleration will be upward. I'm talking here about the pressure difference between the heart and brain. Now, your blood will go out. Therefore, the acceleration will be upward, and the effect weight will be m times g plus a instead of m g. Therefore, going back to Bernoulli equation, we will get the pressure due to the brain equals to the pressure due to the heart minus the density of the blood. Here, if you go back to Bernoulli, it was times g, but here because we have acceleration of the acceleration and the effect of the gravity, it will be g plus a, all of it multiplied by the distance or the height difference between the brain and heart. Now, as a conclusion, the blood pressure in the brain will be reduced even more. My example, here we are going to calculate the acceleration, or at what acceleration would you expect the blood pressure in the brain to drop to 0 for an erect person. Okay, we are talking about standing up position. Let me go back to this formula. The pressure in the brain, pressure heart, and the rest of this. Now, the question telling me the pressure in the brain drop into 0. That means this one will be 0. Now, solve this formula or equation in order to calculate the acceleration. As you can see here, the pressure due or in the brain equals 0 or dropped into 0. Now, move this to the other side. You will get the acceleration is the pressure in the heart divided by the density times delta y, or the height difference. Note that the pressure in the heart is from the first slide. Pressure of the heart is about roughly 13.3 kilopascal, and the blood density is 1.06 times 10 to the power 3 kilogram per meter cube. The height difference is 0.4. Plug it back here, you will get the acceleration is 21.6 meter per second square. Thank you so much, and see you in the next